Today we're going to start with applications on exponential function, and the applications we're going to go over about compound interest, compound continuously, simple interest, pretty much all different types of investments. And probably this is going to make sense for you because what's going on here, we invest money and then we're going to use this formula. So it's pretty straightforward. We're going to, this is your formula sheet. We're going to use compound interest formula. This is the compound interest formula. This is compound continuously formula. So these are the two formulas you're going to use pretty much. Now, let me explain what that means. So let's say you have a lot of money. You don't know what to do with them. I know what you want, what you know. Okay. So this is just hypothetical. We have a lot of money, you don't know what to do, and you're going to invest it. You're going to put it in different investments. So if you put it in compound investment, the way to calculate the return is going to be using this formula. If it's compound continuously, this is the keyword, this is the formula. So now let me explain what compound interest means. So this is the idea behind it. So let's say you invest $100, and if you compound, let's say annually, and let's say you have $100 compound. So the compound, after the compound interest, the word compound, you're gonna see after the word compound, you're going to see one of these words: compound annually, compound quarterly, compound monthly, compound weekly, compound daily, or whatever it is. Compound something. Now, if it's compound continuously, then is this formula, the second formula. But I'm explaining compound interest first. So compound, let's say compound annually. So if it's compound annually, I'm going to write here. So if it's compound annually, you invest $100, doesn't matter where, in a bank or in an investment company. So you invest, and let's say for 5 years, your investment is for 5 years. And what is important, you don't withdraw money from that account, and you don't put extra money in that account. So just put that $100 in the bank, let's say for 5 years, and let's say it's compound annually, and let's say the bank give you a rate of, let's say 3%, for example. Okay, so what's happened here? I'll explain what's happened, and then I'll tell you how to plug it into the formula, and then what is going to be your result. So this is what happened. When you invest your money, after the first year, you're gonna, because it's annually, you're gonna calculate the rate and you're gonna add it to the principal. So the money you start with is called principal. So this is your principal. So after the first year, you calculate the rate and you add it to the principal. Then the next year, after the second year, you're still gonna calculate the rate, but not over the $100. It's gonna be over the $100 plus the interest from the first year. So in that way, your principal is growing year after year. Everybody understand that? So that means your investment is going to be bigger. Your amount you're going to receive is going to be bigger if you invest with simple, what is called simple interest. So simple interest is just put your money. They're going to stay for 5 years in the bank. Nothing is going to happen to them. So $100 stay for 5 years. And then after the 5 years, you calculate the rate. That's the simple interest. Now, the compound interest, you're calculating it every year. And the interest you calculate is going to add up to the principal. So your principal is growing faster. Okay? And I can show the formula, and you see that simple interest, you're going to get less money than compound interest. Okay? Now, if you compound annually, that's annually, n in this formula is going to be 1. If you compound quarterly, n is going to be 4. Quarterly means you're going to calculate the interest every quarter and you're going to add it to the principal, which is going to give you more return than annually, right? Make sense? If you compound monthly, you're going to get more money in the end of the 5 years if you use annually, for example. So if you compound more often, you're going to get better return. You're going to get more money in the end of the 5 years. Okay? Everybody understand the concept? Any questions so far? Okay? So a compound interest, you calculate the rate and add it to the principal. Depends how you compound. Annually, once a year. Also, you can have a semi-annually, which is 2 times a year. Quarterly is 4 quarters, that means 4 times a year. Monthly, there are 12 months, so that's why it's 12, and it's 12. And 12 times you're going to calculate the rate and add it to the principal. Add it, and your principal is going to grow faster. Okay? Weekly, there are 52 weeks, so that's why you're going to do it 52 times. Daily is 365, okay? So everybody understand the concept? So now, if I want to know how much exactly I'm going to get with compound interest annually, or you can do, let's do, so if it's annually, it's going to be less, right? We can do, let's say, instead of annually, you can do quarterly or monthly, okay? So, but let me show you how to plug it in the formula. So annually, n is going to be 1. The principal is what you start, that's your 100. The years is the time. So t is going to be always in years. And the rate always have to be changed to decimal. Do you know how to change a rate like 3% to decimal? What is 3% to decimal? 0.03, that's right, good job. So 0.03 is going to be R. The time is going to be 5. Because the time is always in years, the rate is always in decimal form, the principal is always like money amount, it can be cents also, it doesn't have to be the whole amount, it can be like $100.25, okay? And then annually, quarterly, it's over here, whatever it is. You're gonna look for the keyword and that's what n is gonna be, okay? So all these numbers, I'm gonna plug it into my formula. And let's say the amount I'm going to receive is going to be principal, which is 1. Oh, sorry. I'm just solving example here, and then we're going to do more examples in the handout. So amount is going to be, the principal is 100. That's your original investment. And then you have parentheses. 1 plus the rate in decimal form, which is 0.03 over n is 1. And then exponent n is 1 and t is 5 years. Okay? I'm just going to move this so you can see. Okay? So this is the formula you're using, and then from here, you're going to plug this in symbol up. Okay? You have to put this in the calculator because all these exponents. See, this is where the application of exponents come from, because you have exponent here. Okay? So I'm going to plug this in the calculator. So let me get a calculator here. I'm going to go to symbol app. And you're just going to plug it exactly the way it is. So we're going to plug it in. 100 parentheses. 1 plus 0.03 over divided by 1. And then you're going to get out of the parentheses. In the end of the parentheses, you're going to put that x with the box to put the exponent. And then the exponent, you have 1 times 5. So just enter it exactly the way it is. And then get down. Okay? It have to be exactly the way it is. And that's going to give me how much is going to be the return. It's right here. It's 100. Everybody see that? It's over here. Okay, so after 5 years, I'm going to have $115.93. It's very important to round up. So round 2 decimal places, and Web Assign is very picky with that. So always when you round 2 decimal places, you need to look at the third number. The third number is 7. Okay, so 7 is bigger than 5, so you're going to add 1 to the 2, so that's why it becomes 0.93. Okay, so that's my answer. That's how much I'm going to get. Now, if I compound like monthly, then I'm going to get more. Okay, so everybody understand the idea behind this, the compound interest? Okay, let's do more. So we're going to start with your handouts here. So we're going to start with number 9. That's where we stopped last time. And we're going to start with solving it. So we're going to start with getting all the numbers. So in this exercise, assume that they are not deposit or withdraw. So if you deposit money or withdraw money, then the formula is going to be different. Okay? But here we're doing no withdrawal, no deposits. Okay? So we have the initial deposit of 1,200. So this here is your principal, right? Now, 9% is the interest. So that means what is your R? What is the rate in decimal?
0.09.
0.09. Yes, good job. So the rate is going to be 0.09. You divide by 100. That's how you get it. Okay. Now it says compound monthly. So the word after compound is going to tell me what is N. So what is N if it's monthly? How many months you have in 1 year? 12. That's right. 12. And then they're asking how much you'll be in the account in 6.5 years. So the time always have to be in years. So 6.5 is going to be the T in the formula. Okay. And then from here, we have everything we need to calculate the amount. So I'm going to write the formula first. The formula to plug it in is going to be A equals P1 plus rate over N with exponent NT. So when you plug it in, just plug in the given numbers. So you have 1,200 is your principal, parentheses 1 plus, the rate is 0.09 over 12 with exponent 12 times 6.5. And we have to use symbol up, plug it in exactly like that to get the answer. So here we have 1,200 and the percent was 0.09. Oh, this is 12. And then this is 9. And then this is outside is 12 months and 6.5 years, right? So plug it in exactly the way it is. And then we have to round it. So here we have 2149.29 and 2 after that. So we're just going to cut it to 29. Okay, so my answer is 2149. Oh, 2149. Point 29. Okay, just double check it. 29. So this is going to be my final answer. So far, so good? And you just plug it like that, 2149.29. Any questions on this? No? Everybody good? Okay. Let's do it again. Number 10. The same way. So here you have a credit card, a bank credit card charge interest of 25%. See, the the rate is different. It's not 3%, 9%, it's 25. So that's my rate. So I'm gonna have rate is, what is in decimal form? 25%. 0.25, that's good. And then per year compound monthly. So monthly, what is N? 12 again, okay. If a senior college charged her last tuition bill of 2,000 and intend to pay it in 1 year. So here the 2,000 is gonna be the principal. In this case, she borrowed the money, but still we're gonna look at like investment because she get that money from the bank and she actually have to pay it back. So it's gonna be 2,000 and the time is 1 year. She wanna pay it back in 1 year. And the time always have to be in years. If they give you months, you have to change it to year. So these are the numbers I need to plug it in. And I'm using the same formula. I'm just gonna show you the formula. I'm not gonna copy that again. So here we're gonna plug it in. So I have the amount she needs to pay back is the principal, which is the 2,000. And then 1 plus the rate, which is 0.25 over 12. And then 12 times 1. And then calculator is going to help us out to find the answer. So here we have 2,000. So this is 25%. And this is 12 times 1. Okay, so let's see how much she needs to pay. See, 25% rate, see, for 1 year, she's going to pay 2,500. So 2,561. So it's a big interest of about 500 for 1 year. Okay, and then make sure when you round, look at the next number. After 6 is 3. So you're just going to cut it to 46. Okay, 2561. 46. Okay, everybody understand that? So this is how much he needs to pay. So there are many factors who affect the amount. If you compound more often, the amount is gonna be bigger. If the rate is bigger, then also the amount is gonna be bigger. And of course, if the investment is for many years, the amount is gonna be bigger, right? So this is how they are related with this formula, okay? Now, the next question we have, it's about compound continuously. Okay, so let me explain what continuously means. Obviously, we're going to use the next formula, which is, I'm going to write the formula here for you. So the compound continuously, the formula using it's the amount you're going to get is equal principal E with exponent R and T. So there's no N here. There is no N because when it's compound continuously, N approach infinity. Infinity, what infinity means? Infinity, a lot, right? So what that means, when you compound as often as you can imagine, pretty much, because if you look at your formula sheet here, see, when it's compound annually, N is 1. When you compound quarterly, N is 4. But imagine compound infinity times. So when N is infinity, pretty much all these parentheses inside, it's kind of approaching or looks like E. And E, it's called Euler number. E, it's a number like pi. And E, it's about 2.7. That's how you round it. You know pi is 3.14, right? Okay, e and pi, they are irrational numbers, which means the decimal after the decimal numbers after the decimal point, they continue forever. They're not repeating, there is no order, they continue forever. So numbers like this, they're called irrational, and e it's 2.7. Okay, so now we're going to use e for logarithms a little bit later. Okay, just keep in mind e, it's a number which is about 2.7. Okay, any questions so far? And how you do that in the calculator? You're just going to plug in the calculator. See, instead of all this, you're going to put e in the keyboard with exponent. Okay, I'll show you how to do that in a minute. So if I want to do, okay, so it's just going to put e, and then you're going to press exponent. That's how you do it in the calculator. Okay, so e, it's a Euler number. That's what it's called, Euler. It's the mathematician. So we're gonna use e in the calculator, not 2.7, but the value of e is about 2.7. Okay, so you're just gonna plug it in this formula. So let's see what you're gonna get for number 11. So we have initial investment is 2,000, so that's your principal, right? So the principal is gonna be 2,000. Now the rate is 7%, so what is R in decimal? 0.07, right? Now, if it's compound continuously, this is the formula you're going to use. And what will be the investment in 19 years? So the time is in years, 19. Okay? And you always round the answer to the nearest cent, which means 2 decimal places. Okay? So now what you're doing, you're just going to plug these numbers into this formula and then calculator. So the amount you're going to get is going to be 2,000 is the principal. And then you have the E, RT, the rate is 0.07. You put it in the exponent. And then times 19 also in the exponent. So that's what you're going to put in my calculator. And you have 2,000 E with exponent 0.07 times 19. Okay, so just like that, plug it in. And this is my answer. Now, 7,562, let's copy that. Point. Now, when you copy that, make sure here you look at the third number. So it's not going to be 0.8 cents, it's going to be 0.9. Because after the 8, you have 6. Everybody know how to round up, right? So it's going to be 0.9 cents. Be careful with rounding up because I'm just telling you from experience, this is very common mistake. Like a lot of students like getting the answer right, plug it into the formula, getting it right, but don't round up. If you don't round up, it's going to be wrong. WebAssign is very picky about this, okay? So make sure you look at the third number. Okay, so the answer here was 7,562.09. Okay, so that's how you do this one. And then we have, yes.
Sorry, real quick on the calculator that we have is the, I can't find the E on there.
The actual calculator?
Yes.
Okay, yes, there is an E in there too. Let me, what was the name of the calculator? Hold on.
The TI-36X Pro.
Okay, I just want to get the picture so I can show exactly. Oh.
There is an E on there. If you look at the second key on the top left,
yes.
you look down 2 keys. It shows the E with the square on top of it, along with the cat on top.
Yes.
Just tap that, it'll give you the E.
Looks like E like this. Right?
Yeah.
Okay.
To the right of the same, it's in the same key, but to the right of it, there's a 10 to the power of whatever.
Yeah, okay, I saw that. I just didn't know if maybe it was going to do something funky on my calculator.
Yeah. Okay, let me show everybody. So what was that? IT36 what?
X Pro.
Oh, X Pro. IT X Pro.
Oh no, 3, 6, X Pro, sorry.
Okay. 3, 6, just 3, 6?
Mm-hmm.
X Pro, there you go. Okay, thank you.
Mm-hmm.
Okay, so I'm just gonna open to see the picture, okay? I'm not gonna buy it. Okay, so if you look at this, okay, this is where E is, E with the little box actually. This is the E. Okay, so if you press on this, the first, when you press it once, you exponent and you can type on the exponent. If you press it second time, it's going to give you 10 with exponent. Now, E and 10, they're very common use based. Okay, so E, biology or medicine, they're using a lot of there are a lot of applications using the base E. 10, the base 10 is very common use in engineering. So these are pretty much the two bases. They're very common use. They have a lot of applications, E and 10. And all the old calculators, most of them, they have, later on I'm going to talk about logarithm, which is the opposite operation of exponent. So if you have logarithm, looks like this, logarithm with base a of x, for example. This is logarithm. So the old calculator, they have only logarithm with base e and logarithm with base 10. These calculators you have, so you have here ln and log. This is what I'm talking about right now. So if the base is e, we're using ln. So this is the general form for logarithm. So if you have logarithm, gonna look like this. Logarithm, you need to put base and then x for any base. Now, if the base is e, the logarithm is gonna look ln. If the base is 10, you don't put the base. It's gonna be just log. Okay? So this is where you have ln and log. So when you click on this, right below second, you click once, you're gonna see ln. If you click second time, you're gonna see log with no base. And if you click 3 times, it's gonna be log and you can put any base. Okay? So these are the 3 options for the function ln and log. Okay? So we're gonna use that in a little bit. Any questions so far?
Thank you, Doctor.
You're welcome. Yeah, thank you for asking that. So your calculator have also this ln and log and e with exponent and 10 with exponent. It's right in here. Also, you have this e here, but this is just give you the value of the number. So if you click it once, it's going to give you pi. What is pi? 3.14159 and all the numbers after that. Well, if you click 2 times, it's going to give you what is the value for e. It's going to be 27, and I don't know what else after that. Okay. So this here, the one in the bottom here, the third one, is just going to give you the value of the e, value of the pi, and value of the I. So these are 3 constants they're very common use. So pi, you know what is pi? 3.14. Pi we're using with area of circle and stuff like that. Radians. E is what you're using Euler number. We're using it in medicine, like calculating the exponential growth, decay, and stuff like that. 10 is used, base 10 is used in engineering, and I, it's a complex number. So those of you who are going to IT, we're going to talk about complex numbers, and this is the imaginary constant, okay? So these are pretty much the kind of specific numbers we're using, okay? Any questions so far? Okay, so if you want to know what is E, let me show you E. Oh.
So we're never going to plug in 2.7 into our equation?
No, you don't put 2.7, you just use E, okay?
Got it.
Okay, so this is the value of E, 2.71828, and then many numbers after that, okay? Okay, so I'm gonna go back to my symbol app because I'm gonna use symbol app to show you how how that goes. If you use your calculator, you're still going to get the same answers. Okay, so now here we have one more application in exponents, and we're going to do this. So here we have the amount of drugs, so this is medicine, in milligrams present in the bloodstream T hours after being intravenously administered, can be approximated by the exponential function. So there are a lot of things in medicine which we use in exponential function. You see E with exponent, right? So this is the function. So looking at my function, this is the function. So we're not using the equation for see the compound interest. It's a function with exponent. Continuously function is function with exponent, right? So here we're using a different function which also have exponent, right? So the question is, using this function, how much drug is present in the bloodstream after 13 hours? So the time is T, and they're saying 13 hours. So what you need to do in this formula, you replace T with 13, okay? So I'm going to follow this function, and I'm going to plug in my calculator, negative 1000 E with exponent negative 0.3 times T is 13 plus 1100. That's what you put down. So that's what I have to put in my calculator, right? So let's go ahead and do that. Negative 1000 E, just press E in the keyboard, and then exponent negative 0.3 times 13, and then plus 1100. Is that correct? Let's double check. Okay, so that's what we have. Let's see what we're gonna get. How much is gonna be the drug left in the bloodstream? So here, this is the number. I'm gonna copy the number to see what exactly how exactly they want the answer. So I'm gonna copy and paste this number right here. So now they say round to the whole number, right? That's what it says here. Okay, so if they want me to round to the whole number, that means I'm gonna look, this is the decimal point, I'm gonna look at the number, the first number after the decimal, which is 7. So that means I'm gonna add 1 to the previous one, right? So when I have 1079 plus 1, what I'm gonna get? 1080, that's right. And this is in milligrams, right? Okay, so everybody understand that? Any questions? So we're going to continue with equation of logarithmic equation and exponential equation. So I told you that when you have, let's go here to the formula sheet. When you have exponent, the exponent looks like the exponent looks like 3 with exponent x, for example. That's exponent. And let's say 3 to the x equals 9. So this equation have exponent, right? X is in the exponent. So we're going to solve equations like this, but just operation exponent means multiply 3x times by itself. That's what that means, right? Operation is the exponent. Now, the opposite operation of this is logarithm. So the logarithm looks like we're going to put base, we're going to put something, and then it's going to be equal something. So looking at the exponential equation here, the first one, 3 is called the base, x is called exponent, right? And that equals 9. 3 with exponent x is equal 9. So that's how you read this equation. Now, when I have logarithm, we can change exponent to logarithm because they're two opposite operations, the same way like positive and negative, adding, subtracting, multiplying, dividing, they inverse, they cancel each other. So the same way, exponential logarithm, and I'm going to explain what logarithm means in a minute. So this is how you change it. So the base is going to go to base here 3 down, okay? And then after that, you're going to put 9 equals x. So that's how you switch it. So if you have logarithm exponent, you can change it to logarithm. Looks like this. So let me explain what logarithm means. Logarithm with base 3 of 9 means how many times you multiply 3. So what is the exponent for 3 to get 9? Okay, so let me write that like this. So logarithm with base 3 of 9 means what is the exponent for 3 to get 9? So how many times 3, how many times to get 9? What do you think? 2 times. That's right, Akisha. Good job. 2 times because 3 times 3 is 9. So that means x is gonna be 2. Okay? So that's how you solve it. That's what that means. Okay? Now, what you need to do first, so you don't do anything right now. What you need to do first is, the first few equations is just changing logarithm to exponent, exponent to logarithm. That's what you're gonna do. Okay? And how you do that? I'm going to show you here. It's in the formula sheet. So changing logarithm and exponent. So if I have logarithm given, you have logarithm base a of x equals b, you're going to go to exponent. So you're going to go this way. If you write the base first, then you write this, the exponent equals this. So it's like circle. You switch it around. Okay? So that's how you change logarithm to exponent. Okay? Now, if you have given exponent, so if you start with the exponent, you're going to write logarithm, then you're going to write, so we're going this way now. So I'm writing the base first, then this is what you're going to put in the logarithm, equals b. So for both of those, you're making a circle, you're writing the base first. Okay? So let me show you examples. We have some examples here. We're going to do that circle, going to switch it around. So here we have, when it says write the equation in exponential form, so we're going to switch it. So we're going to we have logarithm, right? So what is the base? The base is 9. And then you're going to write this, and then you're going to write this. So this changed to 9 with exponent 3 equals 729. You don't solve it, you don't do anything, you just switch it around. You got it? And I'll show you how to enter that in WebAssign. But that's the only thing you're doing. You're changing logarithm to exponent. Okay? Now let's do the next one the same way. We're changing logarithm to exponent. So where you're going to start? With the base. What is the base?
8.
8. So I'm going to write 8 is the base. And then what is going to be the exponent for 8?
-3.
That's right. -3 equals what? Everything there. 1 over 512, whatever is given, right? And that's all what you're doing for these equations. You're just going to change it, logarithm to exponent. You got it? Now, let me show you how to do number 15. Number 15, it doesn't ask me to switch it around, but it says find the value of x. So how are you going to find the x? Okay, I explain what logarithm means. So logarithm with base 5 of 25. That means how many times you multiply 5, how many times? To get 25. So how many times? How many times? 5. 2 times, right? Because 5 times 5 is 25. Yes, that's right. Everybody understand that? So the answer is 2. Now you can do this also in the calculator. Let me show you how to do that in the calculator. So if I want to put logarithm with base 5 of 25, you're just going to go here and you're going to put, you see this log? So you're going to press on this. So you're going to click on that and then you have everything. So 5 down and 25 here. So when you enter it exactly like that, it's going to give you the answer is 2. Everybody see that? So it's really easy to find logarithms. Just put it in the calculator. Okay? Everybody good? So the calculator is going to find logarithm with anything, whatever you need. Okay? Then number 16, here we have to switch exponent to logarithm. So here we're going to do the circle again. So what is given? We have given the base, and you're going to switch it to logarithm. So you're going to write logarithm first. Then what is the base? What number is the base?
9.
9 is the base. 5 is the exponent. Okay, let me go here to show again. See, the number down is the base. Think about base is like a basement, something below, there's something above it. Okay, so if you have number and that number have something on top of it, that number is the base. Okay, so the base is down here, it's down. Okay, and see, this is also down, that's why it's the base. So keep that in mind. Base is something down. See, what number is down? 9 is down, right? So 9 is the base. And then you're going to go over here, which is, so you have logarithm with base 9 of 59049 equals, what is that equals? What number is left?
5.
Yes, that's it. So you're just going to switch it around like that, and that's what you're going to plug it in. So now let me show you how to do that in WebAssign. Any questions so far? So you don't do anything now. You just switch it around. Change logarithm to exponent. Okay? You don't solve it, you don't do anything, just switch it around. Any questions? You guys have any questions so far? Okay, let's go ahead and let me show you how to do the WebAssign. So now here, I want to go over this first. Now, number 12, they give me 4 different graphs and they want me to find what is the graph of exponential function. So the graph of exponential function, it's really fast increasing function. So if the base, which one is the base? The base is what? 8. That's right. So if the base is bigger than 1, then the graph is increasing. So if the base is bigger than 1, the graph is going to look like this. It's going to go like this. Okay? So it's going to go close to the x-axis. You never cross the x-axis. And it's going to increase, left to right is increasing. And you're going to cross the y-axis. This point where you cross the y-axis, it's at 1. Okay? Always at 1. Now, if the base is bigger, this is how it looks like. If the base is between 0 and 1, so if it's bigger than 0, it's always have to be bigger than 0. But if it's less than 1, then the graph is going to be decreasing. It's going to look like this. Okay? And again, you don't cross the x-axis. You never cross the x-axis. You're going close to the x-axis. So what is called the x-axis is the horizontal asymptote. That means the graph is going very close to the x-axis, but you never cross it out. And you're crossing the y-axis at 1 again. Okay? So here, in this case, we have base is 8, which is bigger than 1. So I have to see which graph looks like that. See, this one doesn't cross at 1, right? The first one is not right. It's not our graph, right? Because the graph is increasing, yes, but you should cross the y-axis at 1. Okay? This one also doesn't cross at 1. And this one is below the x-axis, it's not this one. So this is going to be the one you have to pick. Okay? Everybody understand that? So now let's go ahead and go over how to change logarithm to exponent and exponent to logarithm. So I'm going to do one of those questions. Okay, so let's pick one. Let's do number 16, 17, 18. Let's do one of those. Doesn't matter. You have preference, or I can just pick one? Okay.
Let's pick one.
Yeah, let's pick 17. So 17, we have exponent, so you need to go to logarithm. So I have to change it to logarithm. Oops. Okay. When I write in top of my screen, it's moving around. So I'm going to write logarithm. What is the base? 3.
2.
Okay. What is going to put after 3? 1 over 80. Okay. And then that's equals, what is equals to? -4, whatever the number is. So this is how I should, yes, so this is how you should put your answer. You need to put logarithm. The 3 has to be a little down. And then you put it like that. So I'm going to show you how to plug this in WebAssign. Everybody understand how to get the answer?
Is it supposed to be 18 or 81?
Oh, that's right. Yes, yes, yes. Thank you. It's 81. Yes. I don't know why I switched it. Am I getting dyslexic or something? I don't know. Thank you. Yes, it's 81. Okay, so now from here, how you plug it in. So I'm going to show you how to plug it in. When you click inside the box, you should see the math path in the end. Hold on. Okay, there you go. So you have the math path. So when you go down here to functions, you're going to see the logarithm there. You see logarithm with the box. So I'm going to press logarithm with base. You're going to put the 3 down. And then with the arrow, you can go to the next one. Inside the parentheses, you're going to put 1 over 81. And then you're going to go out of that equals -4. So that's how you enter it. You go to functions. Okay? So that's how you do those questions. And then I'm going to do one more with changing logarithm to exponent now. Okay, so that's how you do exponent to logarithm. And then let's do one more with the next one here, logarithm to exponent. Let's do 19 or 20, one of those. And 22 also. Let's do 22. Okay, so if I want to do 22, which is log of, no, 22 says find the, so 22 is just calculator. No, I'm not doing 22. 21 and 22 is just find the x, which means use the calculator. Plug it exactly like that. So let's go ahead and do 19 and 20, one of those. Let's do 20 because have fractions. So when you plug it like this, see what it says, write the equation. The next one says find the x. So find the x is calculator, write the equation, you have to write actual equation. So you're going to change logarithm to exponent. So what is the base for number 20? 5 is the base, right? So you're going to put 5. And then what is the exponent for 5? -3 is the exponent, equals 1 over 125. Okay? So this is how my answer should look like. So you're going to go to the box again, inside the answer box. You're going to use your math path. Here you have the exponents. So you're going to put 5 exponent -3. You're going to get down of the exponent and then equals 1 over 125. So your answer should look exactly like this. Okay? Any questions? No? Everybody good so far? Okay, then what is left? I need to show you how to solve equations with exponents. So here you have like 3 equations with exponents, and I'm going to do the one in the handout. Okay, so we have 2 more in the handout, which is solving the equation. So this equation have exponent. Okay, these last 2 equations, they have exponents, and x is in the exponent. So in order to solve this, we're going to make the same basis. What is the base in the left? 27. Darius, can you mute yourself, please? If you don't talk, yes, thank you. Okay, so the basis, you're going to look at the basis. One base is 27, the other base is 3. So what you need to do, you need to make the same basis. How are you going to make the same basis? You're going to get the bigger number, so 27, and you're going to do the prime factorization. You're going to see what is that. 27 is what? 3 times 9 is 27, right? You're going to break it down to prime numbers. 9 is 3 times 3, right? So 27 is actually 3 times 3 times 3, right? So that's actually 3 cubed. So 27, I'm going to change it to 3 with exponent cube. That's 27. With exponent, what is the exponent? X plus 1 equals 3 with exponent 2x plus 1. Okay, so now what you need to do, I need to use there's a property for exponent of exponent like this. So if I have exponent and then another exponent, the rule is you multiply them. Okay, so we're gonna have 3 with exponent 3 times x plus 1 equals 3 with exponent 2x plus 1. Now what happens? You get 3 with exponent equals 3 with exponent. In order for those two to be equals, if the bases are the same, they're already the same, you can cross them out. Now you have to solve the exponent equals to the exponent. So that's what you have to solve now. You're going to solve 3x plus 1 equals 2x plus 1. And this is kind of bringing the x's down so you can solve it. But the bases have to be the same in order to cancel them. You have to have 3 with exponent equals 3 with exponent. And then you're going to multiply 3 times x, 3 times 1, which is 3x plus 3 equals 2x plus 1. And then what you're doing, it's a linear equation. We're going to solve it when you subtract what? 2x in both sides. And you can also subtract 3 in both sides. So we're going to get 3x minus 2x is 1x equals 1 minus 3 is negative 2. So that's my answer, negative 2. So any questions? Oops, negative 2, not 3. Okay, any questions? So we are making the same basis, then cross them out and solve what is left. Okay? Got it? Let's do one more. And you can do a few more. Okay, so this is the next one. Okay, this here should be x squared plus 2x. That's how you read this. So you have 5 with exponent x squared plus 2x equals 125. So now here the bases are 5 and 125. So I'm going to get the bigger number, 125, and I'm going to start breaking it down. So this number is divisible by 5. So 125 is 5 times 25, right? And then 25, you can break it down, is 5 times 5. So again, you have 3 of those 5s. So that means 125 is going to be 5 with exponent 3. Because 5 with exponent 3 means 5 times 5 times 5, 3 times by itself. Okay? So now I'm going to change 125 is going to be 5 cubed. So I'm going to write 5 with exponent x squared plus 2x equals 5 with exponent 3. Right? We change 125 is 5 cubed. Then we have everything ready. 5 with exponent, 5 with exponent. You can just cross out the 5s. And you're going to solve x squared plus 2x equals 3. That's what you need to solve. Now, this is quadratic equation. So what you need to do, you need to move everything in the same side and then use the quadratic formula. So I'm going to subtract 3 in both sides. And then I'm going to get x squared plus 2x minus 3 equals 0. So this is what we have to solve. So here we're going to get ABC and then the formula. I'm going to write the formula here for you. So if you have quadratic, which is x squared plus bx plus c equals 0. And then the x is going to be negative b plus or minus square root b squared minus 4ac everything over 2a. So that's the formula where I'm going to plug it in. So now let's start with a and b and c. What is a? What is a in this quadratic equation? A is in front of x squared. What is in front of x squared? Invisible 1. Good job. Yeah. It's 1. Okay, Jonathan, we're looking at this equation now, okay? So this is where you're going to use the quadratic formula. So the 5 is already crossed out. We don't worry about 5 right now. 5 is not there anymore. Don't worry about the 5. Okay? So what is A? A is 1. What is B? What is the number? B is the number in front of X. Okay, what I'm doing here, I'm doing what you did in week 1. Solving quadratic equation. There is nothing new here. What is B?
2.
2, thank you. And what is C? What is the number by itself? Negative 3, thank you, that's right. Okay? So we're going to get A, B, C, and then you're going to plug them into the formula. So what you have? Negative B is 2 plus or minus square root B squared, so it's going to be 2 squared minus 4, A is 1, and C is negative 3. Everything over 2 times 1. Okay, and then we're going to need the calculator. Or you can do it without calculator. Let's do it, it's really easy. So we have, we need to do the square root first. 2 squared is 4. Then minus and minus is plus 12. 4 times 3 times 1 is 12. So inside the square root I have 16. So what is square root of 16? 4. So what I have right now is negative 2 plus or minus 4 over 2. So I'm going to do plus and I'm going to do minus. So I have negative 2 plus 4 divided by 2 and negative 2 minus 4 divided by 2. So the first one is going to be 2 over 2, which is 1. So the first answer is 1. And then negative 2 minus 6 minus 4 is negative 6. Divided by 2 gives me negative 3. So these are my 2 answers. And let's say what it says. Enter your answer as a common separate list. So here we're going to get 2 answers. One of them is 1, comma. The second one is negative 3. You can put it backwards, doesn't matter. Okay? So that's how you solve this equation. The same way, you make the same basis and then cross them out and then solve what is left. If it's linear, like number 17, you're going to get x in one side. If it's quadratic, you have to use the formula. Okay? So that's how you do this. There's no more quadratic, there's no more equation with exponents. If you want, we can do one more from the lab. Do you guys want another one? Or are you good? Everybody good, or you want another one? Yes, which one? 23, 24, 25? Pick one.
Can you go over 25?
25. Let's do 25. Okay, so 25 we have 6 with exponent equals 1296. So I'm going to start with the bigger number, right? And I'm going to start breaking it down. So I have 1296. I'm going to divide it by 6 because the other base is 6. So obviously this number is 6 with exponent, but let's see how many times you multiply 6. So I'm going to start dividing that number by 6. 1296 divided by 6 give me 216. And then this 260 I'm going to divide by 6 again. So divided by 6 is going to give me 36. And then 36 is actually 6 times 6, right? So how many times you multiply 6 to get 1296? 4 times, right? So this number is actually 6 to the 4th exponent. So that's where you're going to start. You're going to have 6 with exponent x squared plus 3x equals 6 with exponent 4th. And now because you have already the same basis, you're going to cross, I'm not going to move it, you're going to cross it out. And you're going to solve this equal 4. Okay, which is quadratic equation. So what you're doing, you're going to subtract 4. So you're going to get x squared, come on now, x squared plus 3x minus 4 equals 0. And you're going to use ABC to solve it. Okay? So you want to finish it or you got it? You're going to use, what is A? A is 1. What is B? B is 3. And C is negative 4. And then you're going to plug it into the formula, which is negative B, negative 3, plus or minus square root 3 squared minus 4, A and C. Everything over 2A is just 2. 2 times 1 is 2. And then the square root give me 9 plus 16 is 25. Square root of 25 is 5. So I have negative 3 plus or minus 5 over 2. And then when you take plus, it's going to be 1. And when you take minus, it's going to be negative 4. You can use the calculator to double check this, but I'm sure it's right. Okay? So when you plug it in, you're going to have negative 4, comma 1. And then that's my answer. Okay? Darius is asking why the exponent is 4 to a negative. Okay, because, okay, let me answer that. So why 4 is changed to negative 4 here? Because here is why here is negative, right? Because here we have x squared plus 3x equals 4. So you're going to subtract 4 in both sides, minus 4, minus 4. These cancel, and that's how you get negative 4. You got it? Okay, any questions, something else? Let me know. So this is the lecture for today. And I'm gonna stop it. So have a wonderful weekend. Okay, that was for the video. Oops.